Hi guys, here we are. This is the third video. We're on topic number 3, and that last video, sorry, went a little longer than I realized. I guess because we're having so much fun doing math. I'm gonna try to, as much as possible, I try to keep things within the space of a single class. So far we've been successful in always being under about 75 minutes or less, because that's what the time for a typical class. So we're gonna try to stick that again today. But I think we might possibly go over today. I'm not sure. Okay, so we'll do our best here. We're in number 3. Find and graph the inverse of a function. So first, how do you find the inverse? This is kind of like the big thing for this section to me. If you have one-to-one function f, how do you find the inverse? Well, you follow this simple 4-step process. First, you just rewrite the function with y instead of f of x. Sometimes it actually starts as y. Then next, this is the critical step. You swap x and y. And then you solve for y, and you change that, or you rename it back to the inverse function. So whatever y was now, you rename it back to f inverse of x. So those are the 4 steps. And then about the graph, note that the critical step I mentioned a moment ago was to swap x and y's here, right? So when you go to graph an inverse, you're graphing the same function, but you're swapping x and y. And so that means that it's actually going to be a reflection over the line y equals to x. The inverse function, it's like you're exchanging the y's and the x's, so it's going to reflect exactly over that 45-degree angle line y equals to x. Okay, let's try questions 13 to 17. I have them copied down here. We're going to find the inverse by switching variables and then graph them. When I graph them, I'm not going to be super detailed. I'm going to kind of just sketch it out. Here's number 13. So first step, replace with y. I'm going to do that first step right here, 5x plus 1. Second step, exchange x's and y's. Now I'm going to solve. To solve, subtract 1 from both sides. I get x minus 1 is equal to 5y. Divide both sides by 5. Oops. I get y is equal to x minus 1 over 5. Or a better way to look at that is, this is x over 5 minus 1/5. Then it's easier to graph, yeah? Okay, that means the inverse function, f inverse for number 13 is x over 5 minus 1/5. Now let's sketch the graph of those two things on the same plane. First one, original graph was y equal to 5x plus 1. That means an intercept of 1. And then up, so right there, up 5, 2, 3, 4, 5 over 1. So that would be the next point right here. Let's graph that in red. Original function in red. Okay, I'm a little inaccurate, but something like that. Now the second function in blue. So this is x over 5 minus 1/5. So 1/5 would be right about here. And let's see, 1/5 slope, meaning up 1 over, so up 1 would be here, over 1, 2, 3, 4, 5 over here. Something like that. Now keep in mind that this graph, it should be a reflection over the line y equal to x, right? So let's check. What's the line y equal to x? Line y equal to x goes right to the origin, and it goes straight at this 45-degree angle. And look at that. Look at that. The blue line is a reflection right across that line. See, it's like equidistant on all spots from that line I just drew. It's beautiful, beautiful. Great job, guy, drawing that graph. Okay, number 14. So that's number 13. Found the inverse, graphed them both. We saw that they're reflection over y equal to x, which was kind of the key thing I wanted you guys to see. So now let's move on to number 14. 13 is done. 14, first step, rewrite with a y. That's 3x cubed minus 7. Second step, change to y's and x's. Now I'm going to solve for y. So add 7 to both sides. I got x plus 7 is 3y cubed. Now divide by 3. I get x plus 7 over 3 is equal to y cubed. To get y by itself, I want to take the cube root. So y is equal to the cube root of x plus 7 over 3. And there it is. That means f inverse of x is the cube root of x plus 7 over 3. Find my inverse. Now let's go to sketch these guys. Starting with the easier one. Oops. easier one is 3x cubed minus 7. So here I got two transformations going on, right? It's basically a cube root, x cubed graph, which looks like this, but it's shifted minus 7 down, 1, 2, 3, 4, 5, 6, 7 right here. That's my starting spot. And then multiplied by 3. So instead of going up 1 over 1, you're going to go up 3, 1, 2, 3 over 1. So that would be 1, 2, 3 right there. And also down 3 over 1 on the left. 1, 2, 3, like this. Okay, so original function will be in red. Something like this. It's just kind of a rough sketch. Okay. And then here's a line y equals to x. Just a rough sketch of it anyway. That means my other graph, this guy, should be a reflection over that. It should cross at the same spot and then kind of go in the other direction. And then it should sort of mimic that way. And if you look at the shape of that, what I just drew, this is the shape of a cubic function, right? A cube root function, I mean. Right? Yeah. Okay, now let's do this a little more accurately. Let's examine this guy. What's happening with this cubic? There's some transformations going on. There's a cube root, and I'm going to write it like this. This is really 1/3 of x plus 7. So what is the transformation here? Plus 7 means 7 to the left, right? So the original starting spot should be 7 to the left. 1, 2, 3, 4, 5, 6, 7 right here. Okay, and then it's cube root. Cube root normally it looks like this, right? Go up 1, over 1, like that. But this one, I have a 1/3 inside of the function. That means it's a horizontal stretching out. So instead of going up 1, right 1 like I normally would, I'm going to go up 1 over 3, 1, 2, 3, like this. And then here, I'm going to go down 1 over 3 to the left. So 1, 2, 3 that way. So I should have this point here. Okay, so that means if I connect these dots, it should look something like this. Oh, and check that out, guys. You see how that's the reflection? Indeed, it is. Beautiful, beautiful. So that was exciting. Okay, that's 14. 14 down. As I'm doing these things, I'm thinking like, man, maybe I get used to make questions this round, yeah? Like, should have cut a couple out, but I'm actually using actually did cut out some questions from another teacher that I borrowed these notes from. I didn't borrow, actually I made my own notes, but I took a lot of their questions. Anyways, I'm just rambling here. Let's go into number 15. So this is first step, rewrite with y. 2 times the cube root of x minus 9. And then switch to x's and y's. That's 2 cube root of y minus 9. Solve for y. First thing is to add 9. So I get x plus 9 is 2 cube root of y. Divide by 2. That's x plus 9 over 2 is equal to the cube root of y. And then cube both sides to get y by itself. That's y is equal to x plus 9 over 2 cubed. So that's my inverse function. F inverse of x is x plus 9 over 2 quantity cubed. There it is. Now let's do a sketch of the graphs. What's going on here? Graphing this original one first. I've got a cube root with a translation down by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Normally, you remember the cube root function looks something like this, right? Where I go up 1, over 1, and then kind of out like that. But this time, it's 2 multiplied by 2. So it should go up 2 over 1. And then down 2 over 1. So something like that. But still, the general shape should be the same. Kind of like this, just stretched out a little more. Oh, I said I was going to do those in red. Yeah, original functions. So something like this. Rough sketch. Okay, what about this guy? What's happening here with this inverse function graph? Okay, let's rewrite this a little bit. This is really 1/2 x plus 9 to the cube y. So that's a shift 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 left. That's the starting spot. And then this half happens before the cube. So that's a horizontal stretching. And normally I go one up, one to the right. But because it's stretched out, it's going to go up one, two to the right. And then, what is this? Down one, two to the left, like this. But remember, this is a cube function. So cube function looks more like this. Yeah, more like that. And if I track where these guys cross, okay, the last part was a little inaccurate. If I track where these guys would cross, then check this out. Check this out, guys. That is in line with the line y equal to x. So see how those are reflections of each other? Amazing, amazing. Can't believe how it actually is like working. And I'm just doing such rough sketches, but it's looking so cool. Okay, and if you guys ever want a better picture and you want to just check the accuracy, I highly recommend that you check out Desmos.com, the graphing calculator. I meant to actually mention that in the translations and transformations section to just kind of fool around with Desmos graphing calculator and try graphing different transformations of the same function to see what happens. Anyways, we're on to number 16. First step, replace with y. Second step, change those to x and y instead, right? Flipping the x's and y's. That was an x to start with. Okay, now we're going to solve for y. So I'm going to subtract 10 from both sides. X minus 10 is y over 2. And then multiply by 2 on both sides. So I get y is equal to 2x minus 20. And these are just lines. So that's pretty simple. That means f inverse of x. Ooh, that was ugly. Try that again. F inverse of x is 2x minus 20. So just 2 lines, easy. So I do have pretty big numbers, so I gotta make sure I have enough space here. So I have to go minus 20 in one direction, so I'm gonna make it a little high. And I go 1. Oh, stop it. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here I'm graphing this original function. Intercept at 10, slope of a half, right? So over 2, up 1. Something like this. Okay, and something like that. Okay, and then the second one is minus 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Here's the intercept. Slope of 2. So up 2 over 1 like this. Yeah. And I think my lines are pretty inaccurate here, guys. So, good luck making this actually... Oh, that was off. Good luck making this actually match up here, but we get the idea anyways, at least, right? Something like this. Okay, the line y equals to x would be right down the middle, right here. I'm gonna kind of cheat and make it like match my stuff more. What I'm gonna do? So I'm gonna kind of try to follow my pattern here. So here you should cross there, right about there, yeah. So something like that. Okay, if I continue this line, actually it looks amazingly good. Look at that. It actually really is the reflection, right? I mean, this is a pretty rough sketch, but look at that. Look at that. It's the reflection across that line. It's amazing. I keep amazing myself. Actually, I'm not really amazing myself, but I'm amazed that the graphs themselves are what they are, like coming out so beautifully like that. Okay, one more to go, guys. Number 17. My graphs really are not that amazing because they're really just rough sketches and pretty inaccurate. But anyways, let's do this. So first step, rewrite with y and x. Y equals to negative 4 cube root of x plus 3. And then the plus 1 is outside that root. Okay, next step, swap x's and y's. So I've got x equal to negative 4 cube root of y plus 3. And then the plus 1. Now I want to solve for y. So get y by itself. I'm going to subtract 1 first. That's x minus 1. It's negative 4 cube root of y plus 3. Divide by this negative 4. So it's going to be x minus 1 over negative 4 equals the cube root of y plus 3. Now I'm going to cube both sides to get rid of this cube root. So I'm going to get x minus 1 over negative 4 quantity cubed is y plus 3. And lastly, subtract the 3. So it's going to be y is equal to x minus 1 over negative 4 quantity cubed, and then minus 3. Oops. Minus 3. Yeah, minus 3 to both sides to get rid of it. So there's my inverse function. That's right there. Inverse function f inverse of x is that whole thing again. X minus 1 over negative 4, the whole thing cubed, minus 3. Okay, great. That's the inverse. So I found the inverse. Now on to the graphing. And, you know, I am going to go through this one, how to sketch it, just because this is good practice. At some point in the exam, you can expect to have to, you know, graph using translations like this, or transformations, I mean. Translations is just one type of transformation. So, you know, let's just practice so we don't forget. Here's x, here's y. Start by graphing this guy right here, f of x. So what's happening here? Basically, I have a cube root function, right? Remember, cube root function looks something like this. But I've translated first negative 3 to the left and 1 up. So let's start by that. 3 to the left and 1 up. This is my new starting position. Again, it should have this general shape to it, right? But what's happening here? I've got a minus, and it's multiplied by 4, minus 4. So minus means instead of opening up this way, it should open down this way. And the 4 means it should, instead of going right 1, down 1, I'm going to go right 1, down 4. So 1, 2, 3, 4. That's going to be my next point right there at negative 3. Negative 2 comma negative 3. And then I should go 1 left and up 4. 1, 2, 3, 4 over here. Okay, so that's my next point there. This is a cube root, so the general shape is something like this. Like that. Okay. Okay, now we're going to graph this thing. Cubic function, general shape is something like this, right? But I've got some shifts going on. Let's rewrite this a little bit. This is negative 4. Oh, no, sorry. I mean negative 1/4 x minus 1. That whole thing is cubed minus 3. So what is the shifts here? 1 to the right, 3 down. 1 to the right, 1, 2, 3 down. So I have this point right here. Okay. Okay. Now, you know, I regret that these lines are not really accurate, guys. So it's not gonna really look good because I really drew those wide, and these are not so wide. But just that's the reason why it's not gonna look great. It's not gonna match it perfectly. But we'll at least get the gist of how to do this thing. So I did the translations, right? Next thing I have to look for is this negative 1/4. Because it's negative, instead of opening up this way, it's going to open up this way, left and down. And then the 1/4, because it's before the cube, that's a stretch to the left. So normally, where I go 1 up, 1 left, I want to go 1 up and 4 left now. Because 1/4 is a horizontal stretch, right? So 1, 2, 3, 4 over here. Like there, right there. And then 1 down and 4 to the right. So 1, 2, 3, 4, something like this. Something like this. But remember, the general shape for a cubed should be like this. You know, the way I drew this point here, it looks like it's gonna hit this graph, but I don't think that's actually true. It doesn't actually, I don't think it actually intersects there, but something like this. Something like that. And then the line y equal to x would be right here. So you see those, actually, if you look carefully, they do look like reflections of each other. This is kind of an ugly graph because I sketched so poorly. So what I'm going to do is I'm going to make a better graph on Desmos, and I'll show you that at the beginning of the next video.